Okay, good afternoon. Welcome back. Quick reminder of what we did the last two classes. 2 classes ago, we solved systems of equations graphically. A system of equation is just a set of 2 equations in our case, one line and a second line. What were we looking for graphically? An intersection. We're looking for that point of intersection. Graphically, we would estimate. Last class, we talked about solving the same kinds of problems, still looking for the point of intersection, but without relying on the graph, doing only algebra. We had 2 different possibilities. We had the substitution method, and then we had the elimination method. Elimination in your book is called linear combinations method, all right? Yeah, I've seen it. Yeah, I've heard it called the addition subtraction method. Yeah. Okay, the next 2 days, starting today and then going on Friday, we will talk about applications, that is word problems, about systems. I understand that many people feel like they are bad at word problems. The way you get better is to practice. So don't go into today with this attitude like this is going to be hard. Go into it with, I'm going to learn how to solve problems that used to be hard. That's the goal for today. So, any questions on the calendar before we jump in? Okay, and we are here on page 72. So we'll begin with number 1, and we'll go all the way back to Drew. Good. So you just put a positive spin on it. Problem, nobody wants a problem, but we have opportunities. Let's go to number 2 for Davis. Okay, thank you. So to solve every problem today, every story opportunity today, we're going to write down 2 equations, and each of those equations will have 2 unknowns, 2 variables in them. X's and Y's, and then we'll use the techniques from last class to solve. Next page, number 3, Katrina. Okay, so let's think about this problem. If we used only the more expensive candy, and we were making 5 pounds, and it was all the more expensive candy, how much would we charge for that 5 pounds? $20. Everybody see that? And $20 is more than I want to charge. I want to make something a little bit cheaper than that. If we were to use only $2.50 candy, and we made 5 pounds of it, how much would we charge for that? $12.50, right? 5 times 250. I want to charge more than that. So how are we going to make something that's 5 pounds that's worth $17.60? Well, we're not going to use only one or only the other. We're going to use some combination of the 2. Some of the expensive stuff, some of the cheaper stuff. One little thing that we can do here is we can decide which candy we think we're going to use more of. You just told me that if we did all this candy, it would cost $20, and if we did all this candy, it would cost $12.50. If we used half of the 5 pounds for the cheaper stuff and half for the more expensive stuff, what could I do with these purple numbers to find out how much it would cost? Can we go right in the middle? If we use half of the expensive stuff and half of the cheap stuff, then the cost is going to be right in the middle. Anybody have that number for us? How much? 10, yes, and then we add them up. So 1625, I think, is the number that's right in the middle. So if half of the candy were the cheap stuff and half of it were the expensive stuff, we would charge $16.25, which is close. Do you want to use more or less of the cheap stuff? So right now it's costing $16.25. We want it to be $17.60. We need to use a little more of the expensive stuff, get rid of some of the cheaper stuff. Does that make sense? Right now our number is $16.25. We're trying to build that up to $17.60. So we better pour in some of the expensive candy and take out the same amount of cheaper candy. But I don't want to play this game like a trial and error type thing. We could just, we could say, okay, instead of, maybe you use 2.4 pounds of the cheap one and how much of the expensive? 5 pounds total, 2.6, and then we could figure out how much that would cost. And we could just keep going until we eventually landed on the answer, but there must be some better way, a methodical way that doesn't involve as much labor as this would. But at the very least, we believe that we're kind of close to the answer here. We understand that 1760 seems possible. So let's see if we can get it. So first thing we're going to do is define our variables. A lot of times students' first reaction is to write equations. We have no chance of writing the correct equations if we don't know what the variables stand for. So we first think about the variables. How do we know what the variables should be? You read the very last part of the question. How much of each type of candy? Those are the variables. So we've got two types of candy. I'm going to call them cheap and expensive. So I'll use C and E as my two variables. You're perfectly welcome to use X and Y every time, but I always like to use letters that remind me of what's going on. So how about we do, let C equal, don't write the cheap candy. Variables always represent a number of something. Number of pounds of cheap candy. All right, and then how about we use E for the same kind of thing for the expensive candy? All right, and for these kinds of problems, oftentimes it's easiest to organize the information in a table, and then we'll be able to read the equations from the table. So the first row says candy type 1. I'll just arbitrarily choose that to be the cheap stuff and the bottom one to be the expensive stuff. You can swap them. Okay, so let's first fill in the easiest column, which is the middle one, cost per item. How much does the cheap candy cost? $2.50 per pound. And the expensive stuff was $4. So oftentimes one of these columns is very easy to fill in. Now that's $2.50 per item. That's kind of an awkward way to say it. It's really $2.50 per what? Per pound. So then I'm just going to go ahead and cross off per item here, and I'll put pound. You guys have seen that abbreviation for pound, right? LB. I have no earthly idea why it's LB, but pounds. And if I'm saying that items is really pounds, then I think we should change it over there too. Instead of number of items, it's really number of pounds that goes there. And now we're going to fill in. For the cheap candy, how many pounds are we saying? It's a letter. It's C. So that goes right there. C is the number of pounds of cheap candy that we're going to put in the mix. How about right below that? E is the number of pounds of expensive candy we put in the mix. Let's fill in the bottom row. It's a number. It is, but total number of pounds is 5 in this problem. Okay, let's go over to the last column. Total value. Take a step back. When we said, for example, we were going to use all 5 pounds of the expensive stuff, how did we figure out it would cost $20? Then we multiply them. So you took however many pounds you had and you multiplied it by the $4 per pound. Well, we have exactly that, but now it's E pounds and $4 per pound. So we are just going to multiply straight across here, and actually I quite like to fill that in. The first column times the second column equals the third column. That's going to be true for all of our tables today. First column times second column equals third column. So we just multiply straight across. It's going to have a variable in it. It's C times 2.50. I'll write the 2.50 first. 2.50 times C. in the next blank for E. And then again, we want a total. It's going to be a number. What's the total value of the candy? The goal is 1760. That goes right there. Okay, and there is one blank here, the cost per pound total. It doesn't really have any meaning in this case, so I'm just going to cross it off. There isn't anything to put in there. Any questions on filling in the table? Okay, next step is to write down some equations. The equations come from the columns. We filled in information in the rows by multiplying across. Equations come from the columns. C and E tell me how many pounds of the different candies I have, but I know the total is 5. So what equation can I write down? C plus E equals 5. Good. And then the last column gives me the other equation. Same pattern. So it's not a times, it's a plus. Yeah, there it is right there. 250C plus 4E. That's supposed to give us the total value of $17.60. Any questions on the two equations? This is pretty typical for the two equations. You're going to grab the first column, add two things, set it equal to the total. You grab the last column, add two things, set it equal to the total. Let's get, Katrina, did you read part C, please? Aaron, C? Thank you. So the number of items, I'm going to circle in green because that was our green equation, the number of pounds in this case. And then the other equation, I'll circle in black, it was the total value. That's the black equation at the bottom. Now really the only new thing for today is what we just finished. We still have to do all the work we did last class, but the new thing was translating the paragraph into a table into two equations. And now we can forget about candy and we can just solve this doing the techniques from last class. So how about we do substitution? Do I need to do anything to set it up for substitution? What do we need to do? Yeah, you guys remember we need to solve one equation for one letter so we can substitute into the other. So I like grabbing the first equation. Why is it easier to solve the first equation for a letter than the second? Yeah, right. If we solved this equation right here for C, at some point you'd have to divide by 2.5, which introduces fractions. So easier to go with that green equation in this case. So how about we just solve for C by subtracting the E from both sides? And then we're going to take that and plug it into the other equation. Always go to the other equation. So the C that I've just circled in blue is going to become this highlighted stuff right here. So this becomes 250 times C. I'll leave that blank. Plus 4E, 1760. What goes in the blank? 5 minus E. How many variables are in that equation? Just the one. That's the first time we've had an equation with only one letter. That means we've made good progress. What do I do next to solve this? Yeah, let's distribute that 250 through. So we get 1250 minus then we've got a couple of E terms together on the left, so we can group them. 1250 plus how many E's when you mush them together? 6.5? Yeah, it's 1.5. That's a negative 250. So 1.5 E. And at any point, you can stop writing the trailing zero, right? They don't mean anything, but they came from dollars, so I'm keeping them. Again, the goal is still to find E, so first we need to move which number? 1250 by subtracting it from both sides. And then finally divide both sides by 1.50. Just one quick announcement. I've written on the board that I don't have office hours today. Normally I'm available to you right after class on Wednesdays, but again, I've got a committee I'm on and we have a meeting, and I apologize, but I'm not available this afternoon. So E is 3.4. What's left to find? C. Best place to go is the place where it says C equals, right there. It's the simplest place to plug in the answer you just got. So you plug 3.4 for E. So C is equal to 5 minus E, 3.4, 1.6. And that's it. And I think that, well, let's write our sentence, and then we'll see if what we said before was true. So here it says, describe your solution in context. Write a sentence in plain English that explains the meaning of your solution in the context of the original problem. I can't stress enough, I'm looking for the number answers that you just got to be in the sentence. That 3.4 represents 3.4 what? Pounds of expensive candy. So mix 3.4 pounds of expensive candy with 1.6 of cheap candy. That's all the sentence needs to have. If you want, you can say more. You can say you will have a 5-pound mixture, yes, and it will cost $17.60. You don't need to say that. You just need to tell me about your answer. Any questions about the sentence? Okay, and I think what we had said before is true. We had guessed, let's see, so if we mixed equal parts of the expensive with equal parts of the cheap, it would have been valued at $16 and change. So we said we needed to use more of which kind? More of the expensive kind? Did we end up with an answer that was more of the expensive stuff? Yes, 3.4 compared to only 1.6. Questions on that? All right, and I'll say something else. Again, the goal is to be able to organize your thoughts algebraically, and even if you get a question that you can answer by trial and error, even if you can do that in less time than it takes to do this, I assure you we'll be getting to problems that really are not open to a trial and error solution. So even if you can do trial and error, and even if it seems easier and quicker, really try to force yourself to go through the algebra we are building to tougher things, all right? Okay, let's talk a little bit about money in number 4. We'll go back to Joe. Thank you, Sebastian. So do people have a sense of how to solve this? You invest $2,400 for 1 year. The interest rate is 4% per year. Anybody know what to do with those numbers to figure out how much interest we will earn? We multiply them. That's it. So we're going to take 2,400 and we're going to multiply it by, but there's a little trick here. You don't want to multiply by 4, 0.04. Because 4% is 0.04 as a decimal. Remember, you move it 2 places to the left. So at the end of 1 year, we would have earned $96 from interest. Yeah, 4% is a lot higher than anything you'll find these days. Questions on that calculation? Okay, then we will go. We're going to use this formula that we're about to see here. Can we go to Michelle? Okay, so I think that's exactly what we did up here. The principal was 2,400. The rate, the interest rate was 4%. We multiplied them. That gave us the dollar amount of interest, 96 bucks. Okay? All right, let's move on to the next page. And we'll go to Sam. Thank you. Okay, so again, thinking that trial and error is the most natural choice for some of us at this point, one way you could do it would be to take all $2,000 and invest it at the higher rate. Yes? Okay, so I could take all $2,000 and invest it at 9%. We can multiply those two numbers together. I think we get $180. All right, so in that case, we'd get $180 of interest from the high interest rate, nothing from the lower interest rate because we didn't put any money there. And is one of them 37 more than the other? No. Okay, on the other extreme, you could say that all 2,000 could go into the 4% interest rate. And we'll get $80 from the one and nothing from the other. They're still not 37 apart. So then you start to mix. And you say, okay, what if I decide that I'm going to, for example, I'll just pick a number. I'm going to put $800 into this one and how much into the other one? We have 2,000 total, so 1,200 in the other one, right? We're just divvying up the same 2,000 every time. We could find how much interest we got at 4%. We could find how much we got at 8%. We could cross our fingers, hope and pray that the difference is $37. But this is really a laborious process to do, right? And what if the correct answer is actually what we're supposed to do is $509.42 at the inexpensive one? It would take me a long time to get to that, right? It would take a long time. Okay, so let's see if we can do this, not trial and error, but using the same tools we used before. First step is still define your variables. The place to go is still the actual question. This is a big statement here, but there is a question at the very end of it. How much did he invest at each rate? Those are your variables. You're going to let some letter represent how much he invested at the low rate and another letter for how much invested at the higher rate. I'm going to call them L and H for low and high. L equal what? That's fine. What are the units for L? Dollars. L is the amount invested at the lower interest rate in dollars. And then for the other one, so what letter could we use? Okay, let's fill in the table. Table has different columns now. Amount of money invested. Last question, it was the number of pounds of candy. Middle column is the interest rate. Last time that was the value of each of the kinds of candy. Last column is the amount of interest or interest income. Before it was the total value of the candy. Again, one column is quite easy to fill in. It's just numbers. Somebody we haven't heard from today, which is the easy column? Ben, interest rate. It's given, it's numbers. The first bank, I'm going to go ahead and call the first row the low interest rate and the second row the high one. Again, you can swap those. So what is the interest rate at the low bank? 0.04. Make sure you do not put 4 there. You got to convert that to a decimal. At the high interest rate, I only caught the tail end of a little news blur, but is the stock market like at an all-time high now or something? Was yesterday it closed higher than it ever had? Yeah. Okay, next we're going to fill in the first column, amount of money invested. These are just variable names. They're just 2 letters you're going to put in there. How much did we invest at the low interest rate? We called it L. At the high interest rate, we called it H. Total is supposed to be a number. It's given in the problem. $2,000 is what we had total. What we saw on the previous page was that if you take the principal, the amount of money you start with, and you multiply by the interest rate, that tells you how much interest you earn. So the principal is that first column. Put a P up here for principal. This right here is the interest rate. If I multiply them together, I get the actual amount of interest. That's the formula we saw on the previous page. So how do we get the last column? Multiply the first 2, just like we did with the candy. So we multiply. L times 0.04, I'll put the 0.04 first. Multiply in the next row. And then the total, I don't know. It doesn't say. It doesn't tell you how much interest you earned, right? It just says there's this relationship. One of them is 37 more than the other. Sam? Yeah. So there is a relationship given, but it's not that. So I'm going to cross off the total because I don't know what the total is that we earned. I know we had 2,000 to start with, but I don't know the total of the interest that we earned. The interest rate total, it doesn't make sense to add 4% and 9%, so we'll cross that off too. Don't feel like you're obligated to fill everything in the table. The table is just supposed to help you. Some of the blanks don't get filled in. Okay, still looking for 2 equations now. Tenzin? On the test, I don't know whether or not I'm going to give you the table, but if I do give you the table, it is going to look a lot less helpful. It's going to look like the ones on the next page, where it'll just be, if you turn the page, you'll see a prettier table than I have here. Don't know. It is. I mean, this is a picture, like it's not scanned, but it is a photograph. I mean, I can't edit this. It's not text anymore. So it is a picture, and sometimes when you take digital pictures, you lose quality. Okay, so if I give you a table, it will be all blank. So you'll have to fill in the headings on your own. Okay, let's get the first equation. The first equation is going to come from the first column. Everybody buy that? We have $2,000 to invest, so the total of the two investments must be $2,000. And before we write the other equation, let's just pause and recognize how similar this problem is to the candy one, even though interest and candy appear to have nothing to do with each other. Just like before, one column was easy to fill in. In the candy problem, it was easy to say that this candy is $4 a pound. It was given. That was one column. Just like before, how do you get the third column? I mean, you multiply the first two. That's going to be consistent. To get the third column, you multiply the first two. And also consistent is that in the first column, right in here, we have an equation. L plus H is 2,000. You had a similar equation for the candy problem. I forget, C plus E equals 5. Just add them straight up. A little bit different. Here we had a number in the candy problem. We knew it was $17.60 total. We don't have that here, but we have a different relationship and we just need to capture it. Here's what it says. I'll highlight the phrase that's important. It says the income from the 9% is 37 more than the income from the 4%. Okay, that's what we need to translate. I'm going to squeeze it in right up above here. The income from the 9%. All right, I don't know what to put there yet, but I know what symbol that translates to. In math, what is? Equals. Okay, so I'm translating equals. 37 more than. In math, how does that translate? There is a plus, and there's a 37. So you can either put the 37 first or after. I'll put it first just so that it's in the same order as my highlighted things. So that's what I have right now. Let me change this to blue so we can highlight in different colors. Let's do that. Yellow for this guy. Okay, so yellow thing needs to go up here. Green thing we've already got. And then the blue thing needs to go right in there. Okay. The income from the 9%, that is to say the interest that we earn from 9%, I don't know how much it was, but I do know that's exactly what this column is calculating for me. This last column tells you how much interest you get from each investment. So the amount of income from the 9% investment, it's got a variable in it, but it's that. That expression right there is how much interest you earn from your 9% investment. That's the hardest part of this problem. That expression tells you how much interest you get from the 9%. If you decided to put all of your money in the 9%, how would we figure out how much interest we earn? How much money do we have to play with here? 2,000. If you put all of it into 9%, what do we multiply? 0.09 times the 2,000. Well, that's exactly what this is. 0.09 times, well, I don't know if it's 2,000. It's some amount of money. I called it H. So that 0.09H goes right up here. That's the amount of income from the 9%. Where will I find the income from the 4%? It's right above. That right there is the income from the 4%. 0.04 L. Questions on that equation? Sam? You are welcome to, yeah, you're welcome to put parentheses to really kind of group 37 plus whatever. Parentheses are super important when it's multiplication, but if it's addition, it doesn't change anything in this case, but it's fine to include them just to be safe. All right, so I'm going to copy that equation down below. So it was 0.09H equals 37 plus 0.04 L. That's our equation. And now that we have two equations, we can solve it just like we did last time. We're done thinking about the money in this case. Now this is just a strict process, strict algebra. One thing I'd encourage you to do at this point is get rid of these decimals. how can we get rid of the decimal? Yeah, we're going to multiply both sides of that bottom equation by 100. Because multiplying by 100 takes decimal points and moves them 2 places to the right. So I think that's a great first step. 100 times everything. 100 times 0.09. Move that decimal place 2 to the right. Gives me 9 each. 100 times 37. 700. Plus 100 times 0.04. 4. It doesn't. No, you don't need to do that. Yeah, it just gets rid of the decimals. But if you just carry through the decimals and you're careful, you'll get the right answer. Okay, so we've got our equation here. Again, to me, it seems easier to do substitution here. Would you solve the first equation or the second equation? First one. First one doesn't have all those extra numbers in them, so no division. So first equation, you can solve for whatever letter you want. What letter do we want? All right, let's solve for L. So subtract that H from both sides. Okay. And then we're going to copy the second equation, but instead of L, we're going to put all of this. I'll have to introduce new parentheses here. So this is kind of what Sam was talking about before. Because it's multiplication, we need those parentheses. Questions on that equation? Okay, so then we'll distribute. Bring all those h's over to the left by adding 4h to both sides. Is that 900? Maybe I made a mistake. $3,700 plus 8,000.
No, I got 117.
This looks good. And then when you divide?
I got 1521.
Try dividing again. So this number is not right, that 4,500. Add those two guys again. Okay, so we've got 900 for H. What do we still need to find? L. Best place to go is the equation that says L equals. So there it is, L equals. So just plug your 900 for H right there. Any questions on the process? It's a lot of steps. The new thing today, I think, is basically the table. I like the idea of organizing all the data. There's a lot of information in this problem. Organizing it in the table, I think, is a good way to go. And as you do this a few times, you'll start to recognize, oh, the same table keeps popping up, and it's the same rules governing the table every time. Okay, let's write down our sentence, and then we'll do the group activity. Okay, so Jerry invested, and then we'll get the first part of our answer. 900 what? $900 at the 9% or at the high percent. And he also invested $1,100 at 4%. Should have done the other way. Yeah, the tricky thing, I mean, why wouldn't you just put it all in the 9%? And the idea is that you oftentimes don't know ahead of time what the interest rate is going to be. And usually the way it works is the higher potential interest rate, what's the downside? That's not a math question. This is more of like just a economics. What's the downside? You know, like you've got these things that have the potential of being high interest, like a 9%. It's the risk, right? It's you can go for the gold and put it all in the 9%, but the 9% is probably quite a bit riskier than the 4% one. And so you might not get 9%, you might get 2%, you might get negative 5%. So it's this kind of balancing act that you play. All right, so group activity we're going to do a little bit differently. There is a step-by-step process written out here. We're not going to read this to each other, but maybe as you're working in groups, if you need a reminder, or tonight, if you're looking over the process, this would be a good place to look. But let's do the group activity. There are 5 different problems here. There's not enough time for everybody to do 5 different problems, but what I'd really like to happen by the end of class today is that a group has done each of the problems and that we've got them up on the whiteboards here. So the goal is to have all 5 problems up on the whiteboards solved completely so that people can take notes and look, all right? Okay, so this table all the way in the back, you guys are going to start on problem number 1. And once you've got it, put it on this board up here in the front. And once you're finished, then move on and try number 2. You guys start at 2, you'll start at 3, you will start with problem 4, and you will start with problem 5. And Dave, you can join a table of your choice, maybe this one in the front or in the back there. Either here or there.